Hi, this is Chris Hallenbeck, and I'm here with my colleague, Eric Schneider.
Hello.
Today we're here to help you explain that question of how to answer, is S4 really a brand new innovation, or is that just a marketing blurb by SAP? So with that, I'm going to turn it over to Eric, and he'll start this out.
Okay. So before there were computers, there was paper, right? So we had documents. We had a purchase order, we had a sales order, we had a manufacturing order, or accounting document. Or in SAP speak, we had documents in SD, in MM, as in materials management, in finance, and in manufacturing orders, and also in plant maintenance. So all our core modules, except HR, which is a separate issue, the business processes were represented as documents. Those documents 40 years ago in R1 or R2 were represented by tables. The central core table to represent a document is the line item table. The line item table is like typically a row table split into keys, can be multiple of them, and dimensions, and of course quantities and currency. And there can be multiple of them. There can actually be so many that we have up to 200 fields in a single line item table. So if we now switch on an industry solution, what that technically means is we append the existing line item table and add just another 100 more fields. So when we take the retail industry solution, we easily end up with 350 fields in a line item table. So what happens now in traditional database design, if one value changes, let's say from a 1 to a 2, then the whole record gets replicated in the system. So even if only a single field changes the value, the system will replicate the complete data set, and we have another 350 fields. So when we take the area like in sales and distribution, where we have a sales order, a delivery, or an invoice, the invoice doesn't change that often, but a quantity on a sales order can change quite a bit. So we not only have one table, but we will have many tables, and this set of tables is then called the change log. And the purpose of the change log is also, from an audit perspective, to keep track who changed the order quantity or who changed a price on a sales document. Because if one field changes, we have to replicate all the 300 fields, then already 40 years ago, the application designers had the idea, let's split the document in multiple tables. So the line item, and as a basic concept, a header table. So we not only have in those application modules the line item table, we also have a header table. And of course, a header table has less fields, let's say 10 to 12 fields. But same concept applies here. One value changes, the whole record gets replicated. And in addition to header tables, we can have status tables just for the header. Same thing here. One field changes, the whole record changes. Of course, the line item table also has its own status, and particular in SD, we have another complexity. We have a schedule line item, and the whole concept gets replicated over and over again. In certain areas, we can have over 40 tables representing a single document in a business process. And this is all to support traditional databases.
So I think we've seen this structure before, and we see these keys, and we also know, though, that then we have all these different constraints. So I have database constraints, and we're used to seeing these things and saying, all right, there's this crow's feet, and then to this one, there's a many-to-one relationship here, and this goes on for all those 40 tables. Well, that all has to be tracked so that I make sure that the database is consistent. And that's what database management system's done. But the more tables that have to be tracked, and more often what is called locking and latching, is very, very difficult and slows down a database tremendously. It's also a very difficult aspect for a database administrator to deal with. We hear about, oh no, the database locked up, or the table locked, take the users off, or there's page level locks, and then you keep going up and up. It's a huge issue. So one, massive complexity induced by this table structure, by having this, in order to consume space, which we see isn't even that effective. The next thing is these table structures to go and get reads and get any information out of them is too slow. And we know when a database is slow, you do something and you start adding indexes. So for every one of these tables, for a method by which it wants to be read, is the SAP's own developers knew how the system would be used, and they started to add indexes. And unfortunately, it wasn't on a per table basis. It wasn't one. Every single table up here has several indexes assigned to it. Now, let's be clear. An index, although it doesn't have to be maintained, an index is a table. It is a copy of the data based on a narrow method of access. So in order to overcome the fact that this system is slow, we have to create yet more copies of the data, taking up yet more space in order to make the system more narrowly usable. Now, it turns out that even the indexes aren't fast enough. So in fact, we have to start to go in and add aggregates. These are whole new tables that SAP's code has to manage, so now I have more complex code to be built and tested that actually go in and maintain these to do things like daily totals of all the invoices, all the changes that day, the quantities, weekly totals, monthly totals. It just continues on, and then more code to maintain those, all to get better reporting and speed the system. And all we've done is induce complexity, more code, and more tables and structure. The idea ultimately is how we get away from this.
So important to note is also that those index and aggregate tables are two types. The ones which SAP has designed and delivered. And the standard index and standard aggregate tables, they are actually used in the standard code. So what are all these database administrators now doing? They analyze the system and the particular usage for a particular customer. So they will add, like the famous Oracle DBAs, additional indices. That is their job security, and that is their art to identify which particular fields of this original table assembly we have to replicate in those custom DBA index tables and aggregate tables. So it's not only that we have additional work to do for each release, upgrade, each modification, but the system also has to do additional work. Because if the value changes over here, it's not only that we have to rewrite a whole new record. This field also the change has to be reflected in the index table. And if this is a field which is very often used, you have to actually do this for every single index delivered by SAP or delivered by, maintained by the DBA. So this complexity overall increases not only the cycles for release upgrades, testing user exits, testing modifications, but if you imagine now you want to build a report, and you want to build a report to represent my sales order in a dashboard, then you have to know the logic, how the fields are linked to each other, not only to do the one-time dashboard, but then you also have to know which particular activity in the business process triggers a change in which table. So this is where BW had a dominant role, because all the logic, all the intelligence, how those fields interact with each other and when do they get updated based on which process, batch run, or user entry, was reflected in the extractors. So the BW extractors, they took care of this spider web of tables to build a logic which made sense to the end user.
So let's talk about, why S4? Recognize this was brilliant at its time when we're going back to the original databases that were written back in the previous century. This was the only way to make a performance system that could run the likes of Colgate-Palmolive and General Motors and Siemens. Yet can we make the system simpler? With S4HANA, we did several things. We were able to start to drop the indexes. We could drop some of the aggregates. But the fundamental aspect of what all these documents and the relationships and the tables required to maintain them was unchanged at the time in order to have reverse compatibility for customers. S4 is a complete rethinking. a complete rewrite of the code, but then also leveraging the capabilities of HANA that goes way beyond dropping indexes and aggregates into rethinking the entire structure and simplifying it for both the customers and for the developers to make a much easier system to understand and a much more agile system for our development staff.
Okay, so why is S4 now a really new product? So we still have the document concept. That doesn't change. And what we do now is that we still have a record, but this record is not a row table anymore. That record is now represented by individual columnar stores for each of the fields. The big difference is if a value changes, we just insert one new field. We don't replicate the whole data record. So for example, S4HANA 2.0, the universal ledger, we have close to 400 fields. That would be almost impossible to run in a relational database, especially without any indices or any aggregates. So with S4HANA 2.0, we have 400 fields represented as a record, but each field has its own columnar storage. That means every field can serve as an index. So this is a dramatic change. And when we looked at the code which is required to do this, SAP didn't make an easy decision and said, oh, let's just start from scratch. I mean, we tried this, and in order to take really full advantage of the new concept, we had to break with the old code line. And I mean, when we look at these two pictures, it also becomes obvious that currently you can't run this on a DB2 or on an Oracle or an SQL database, no matter what our competitors say, as long as they catch up on the concept of having for each field a columnar storage and following the insert principle.
Yeah. So let's kind of go back up and look at this at a little technical level. So, you know, in the worst case that Eric described, we had 27 tables, and that doesn't even talk about all the indices and the aggregates. We're now down at 1. And yeah, that's absolutely a much wider table. We're back to 400 instead of shrinking it down through this process of what's called normalization. But because it's in a columnar structure and because we only update a value, a single value when it's changed, it's actually not an update, it's an insert, we don't have huge space concerns, and the performance is still phenomenal. Now we go back to, and we talked about the update problem, the locking and the latching when I have all these tables that have to be maintained. I have none of that here. Yeah, I have to take out one single lock for a split millisecond while I do the insert of the new value. That's it. Done. It's off. So the throughput of the system, what most people call the OLTP speed, but the throughput, which is a better way of thinking about it, is dramatically higher with S4HANA than it has ever been, even whether it was HANA running here, and certainly when we looked at Suite on AnyDB. Then we also look at, let's just go back through and remind ourselves, when you, instead of aggregates now, HANA speed enables it to scan all the relevant rows and add them up much faster than it could even read this. So the aggregates are gone. Want a new report? I don't create a custom aggregate table as a DBA to go get a different report for the company. I just write the reports here, and HANA builds it on the fly. I don't need any of the indexes to speed it up. The ones created by the DBAs are the ones created by SAP's own engineers when they define the data structure. I don't need any different status tables or headers. The entire thing has been collapsed into a single line item, or really what's a single document line all together. All the code that went into maintaining all of this separately and no understanding that, all gone. So the actual code line itself is radically simpler. Now when I think about the testing and regression required, all of that is radically simplified, which means a much higher quality process. And the variations and the splits of updating things, the number of things that could go wrong over here were tremendous. The number of things that can go wrong when I code against this, quite small actually, improving quality as well. So as you can see, S4 is a huge innovation, leveraging something that wasn't possible before HANA due to both its ability to have a simple system and ability to do aggregates on the fly. All enabled here. And it's an entirely new code line pointing at this much simpler structure and leveraging that. The last thing we'd like to talk about is one of the things our engineers also did during the process was this table structure was incompatible with going to a multi-tenant cloud. So sure, I could host in a hosted data center, but to actually stick this in one big cluster, which many of our customers, or they want a division or a certain country to be in a multi-tenant system, was impossible. When we did the migration to the new code line for S4, they designed it in such a way that of course it can run on-prem, or else I can take that same code and run it I can run it in a hosted environment. It equally can run in a multi-tenant cloud. So smaller companies want to run it there, but as they grow, they know they can go on-prem, they can run in a hybrid system where certain divisions are running in a multi-tenant system, some are in a hosted and some are on-prem, and I can move back and forth with portability. That is not possible with any other ERP made. And so S4, a huge innovation and a huge jump for our customers. So the next time you're asked and you're saying, is S4 a true innovation? Now you can explain part or all of this about why this is so unique. And then ultimately, Eric and I'll come back to you in other videos and we'll discuss the business benefits that this is now enabling that were impossible before on this structure. Thank you very much.